Howdy, this is MXET 300 Mechatronics 1 final project proposal for Section 506, Group 17 for the Sentry robot.
So for our project, the objective is to model a security robot to detect and follow nearby motion while avoiding static obstacles in the room. So for this, we want to do a fully autonomous system that will be following a patrol path in the room in a grid pattern. And then we want to scan each grid zone at certain intervals to find the intruder in the grid, and then spotlight the intruder and follow it as it's moving. And then we also want to maintain a distance from the intruder as our dynamic obstacle avoidance.
For our plan of execution, for the mechanical, we want to construct a mounted system for our light and our buzzer, and also install a mount to the scuttle chassis frame. For the electrical and components, we want to establish wire connections from the PI to the electronic components, including the light and buzzer system and an external battery pack. And we also need to build the circuitry for light systems and buzzer to create an alarm when the intruder is spotted.
For software, we're planning to create a global map of the room using LiDAR point clouds and in the equations that were put in the lecture. We're planning to create an algorithm to define and follow the patrol path to monitor the area, like the grid zones mentioned earlier. We plan to code a motion detection system using that point cloud to spot the moving intruder. We're going to define an algorithm to calculate a path from the robot to the found intruder, and then an algorithm to pursue and intimidate the intruder while avoiding obstacles. And lastly, we needed embedded systems programming to send signals through the PI to the pins for the light and buzzer control.
So my task will be to create an algorithm to make a path around the room and define the grid pattern that we'll be using for our patrol path. And then also programming the basic movement for the robot to follow this grid pattern. And then also finding a path from the current location of the robot to the intruder after it's spotted.
My task will be taking and coding the embedded systems for the Raspberry Pi pins to control the operational light and buzzer system. I'll also be integrating the software, hardware, and other components of the system to fully operate in a stable state. And I'll also be working on the documentation and monitorization of members and their progress through the archiving on GitHub and communication with the group.
I'm responsible for constructing the transistor circuit used to control the switching logic for the light and the buzzer system. We'll also be designing and installing the mounting system for the light and buzzers, and then also the electrical connections between the light and buzzer, Raspberry Pi pins, and an external battery.
I will be responsible for creating the global LiDAR point cloud map as an array by converting the LiDAR data points to a global frame. I'll be developing the motion detection logic by comparing object displacements between consecutive global frames. And then I'll be creating a feedback loop to allow for precise and consistent navigation.
And I will be making the code algorithm for the intruder pursuit using the path to the intruder that was previously found. I'll also develop obstacle avoidance logic so the robot can maintain a distance from nearby objects and not collide. And lastly, I will implement a decision-making system that will transition between the robot's behaviors.
For the timeline of the group project, the embedded systems will be worked on throughout week 1 to about halfway through week 4 for the flashlight, buzzer mount, and wiring, mostly by Caden, but also by myself, while the LiDAR will be worked on about the same time. For the global point cloud mapping and motion detection by Jacob, and obstacle avoidance by Daniel.
For path tracking, for week 1, we'll start working on patrol path creation and intruder pursuit, with path following being worked on midway week 2. And then following that, our integration and testing we'll start performing by the end of week 3, finishing up week 4, and then we'll finalize our documentation and report our demo work will be turned in by the end of week 4 and week 5.